All right, today we're going to be looking at coordinate geometry, specifically at the midpoint formula and the distance formula. And the midpoint formula is what we're going to use to find the midpoint or a single spot in the middle of a line segment. And we're going to do this on the Cartesian grid. And sometimes it's quite easy to identify, oh, well, the midpoint in that line is right there. I can count squares, but counting squares can become tedious if you have many squares to count. So what we can do, I'm going to label these points A and B and talk about them. A is located at the point 3, 3, and B is located at the point 5, 3. And for all purposes, when we want to find the midpoint, essentially we are going to find the average of the x values and the average of the y values. So I'm going to write this down here. Midpoint, to average x values, we're going to take the two x coordinates, add them together and divide by 2. And we're going to take the two y coordinates, add them together and divide by 2. So this is our general go-to for finding midpoint. It's the formula we're going to use on these numbers to confirm whether or not 4, 3 is in fact the midpoint. So let's do that down here below. The average of the x values, x2 plus x1, would be 5 plus 3 divided by 2, and the average of the y values would be 3 plus 3 divided by 2. And 5 plus 3 is 8 over 2, and 3 plus 3 is 6 over 2, which does in fact reduce down to 4/3. So that, or not 4/3, 4, 3. So that confirms that. So all we need to do is know the coordinates of the endpoints, and then we can find the average. So this first point occurs at 2, 1. The second point occurs at 4, -3. So to find our midpoint, we are going to average the x coordinates, 4 plus 2 divided by 2, and then we'll average the y coordinates, 1 plus -3 divided by 2. Actually, I'm going to write that slightly different. That should be, let's write that as -3 plus 1. That way we attend to those first numbers being one point and the second numbers being the other point. 4 plus 2 is 6 over 2 is 3, and -3 plus 1 is -2. -2 divided by 2 is -1. So we should have a midpoint at 3, -1. 1, 2, 3, -1. And that does, in fact, look to be the midpoint of that line segment. Okay, you don't have to have the graph. You can execute these midpoints simply by knowing the coordinates. So here we go. Let's average the x values, 4 plus 0 over 2, and average the y values, 6 plus 0 over 2. And that would be 2, 3. Pretty straightforward. Midpoint is the average of each part of the coordinate pair. So the average of 3 and 6, the average of 8 and 1, nine halves, 9 halves. Or if you were to write it as a decimal, 4.5, 4.5. On the next one, we average and we see they're just opposite signs of one another. So there's what's called odd symmetry going on there, and we should get something unique. So the 2 and the -2 cancel out, the -4 and the 4 cancel out, and we get the midpoint occurs at 0, 0. And the last one, 5 and -6, and 2 and -4. add those together, we get, looks like we're going to have a decimal again. Negative 6 plus 5 is negative 1/2 when we divide by 2. And then negative 4 plus 2 is negative 2. I'll go ahead and write it negative 2 over 2. And then if we are to reduce that, we could have negative 1/2 comma negative 1. Or if we were to write it as a decimal, negative 0.5 comma negative 1. Any one of the three answers works, though I tend to favor things that are simplified, and if they can be expressed as fractions, usually fractions are better, in my opinion. Decimals become more valuable when they're word problems and we're trying to understand relations of the numbers. But all right, that's midpoint formula. We're gonna take a quick breather and then we'll dive into distance formula.
Watch me, you can, and follow. Hold your lightsaber upright, then swing.
All right, we have the distance formula, which I'm going to go ahead and write down up here. Capital D for distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's a pretty ugly looking formula and perhaps maybe even sort of difficult to memorize. And so I'm going to approach it a slightly different way, and then I'm going to show you why this formula works, and you can take either of the two approaches that works for you. So I want to find the distance between this point and this point. And so what I'm going to do is I'm going to actually kind of think of this as a right triangle. I'll sketch it over here off the grid so it's not crowded. And I'm going to look at the length of the sides. The length of this side is 1 unit. The length of this side is 4 units. And the distance would be the length of the hypotenuse of a right triangle. And we know the Pythagorean theorem. It tells us that the length squared plus the height squared is equal to the hypotenuse squared for right triangles. So 1 squared plus 4 squared equals hypotenuse squared, and we get 17 is equal to hypotenuse squared. And we find that the distance between those 2 points is the square root of 17. This is intuitively easier to follow, in my mind at least, than this formula. But what does this formula actually represent? We see the square root, and then we have the distance between the x-coordinates. How far apart are the x-coordinates? That's just the length of the base squared. And this is the distance between the y-coordinates, which is just the length of the height squared. So this is actually just a symbolic way of rewriting the Pythagorean theorem. It's really the same things. You know, most mathematicians would argue there's no difference between these two processes. I just find this one a little bit easier to get a hold of. So as a reminder, the Pythagorean theorem says a squared plus b squared equals c squared, or the length of one leg, if you were to square that and then add that to the length of the other leg squared, you would get the length of the hypotenuse squared. So geometrically, we could say the area of this square plus the area of this square is the same as the area of that square. And there's actually hundreds and hundreds, if not thousands, of proofs for why this statement is true. And it's something that I prove later on in mathematics class, but not at this level. But it's kind of an exciting problem because so many people have proved it in so many different ways. All right, how far apart are these points? Well, let's make it a triangle. And then we have the triangle. It has a base length of 1, 2, 3, 4 units and a height of 2 units. So we can say 2 squared plus 4 squared is the distance squared, or the hypotenuse. And that's 16 plus 4. I'm just going to go up here. 20 is d squared, which means the square root of 20 is the distance. And this number here does have a perfect square in it, so if we were to simplify that radical, we'd have root 4 times root 5 equals the distance, or 2 root 5 equals the distance. Now, since this skill is focusing on just calculating distance, that's kind of as far as you need to take it. Although if you were to take a multiple choice question, undoubtedly the answer would be expressed as 2 root 5. So it would be ideal if you can simplify your radicals. Next up, we have another triangle here, and we want to find the distance between the 2 points. So let's turn it into a triangle and count squares. 4 to negative 4 is 8 units, and 1 to 4 is 3 units. So we can set up 8 squared plus 3 squared equals distance squared. 64 plus 9 is 73. And if we square root both sides, we get root 73, which doesn't have any factors, and it certainly doesn't have any factors that are perfect squares. So I think 73 is a prime number. I can't think of any factors off the top of my head. Okay, so using the formula, I'm going to do it with the formula and then show you without the formula here. We could say the distance is x2 minus x1 squared plus y2 minus y1 squared, and that's our distance, which is the square root of 16 plus 36, which is the square root of 52. Okay. So that's using the formula. Alternatively, you can, again, go to the idea of there being a triangle. So I'm just going to write a triangle here. It doesn't really matter which direction you draw it, but here's a right triangle. The x distance from 3 to 6 units is 3, and the y distance from 8 to 1, that's a distance of 8 minus 1, that's a distance of 7. And so I've got this triangle that's 3 units on one side and 7 on the other. 3 squared plus 7 squared equals distance squared, or hypotenuse squared. And that's 9 plus 49 is 58 equals d squared, or the square root of 58 is the distance. Either approach works. Now, while I say that this is my preferred approach, I absolutely understand the value of this approach. And later on in mathematics, there is actually something that I teach in calculus class where we really want to know this approach. But either approach works for where we're at right now. So let's just go with the triangle approach. What's the distance from the x-coordinate to the next x-coordinate? Well, negative 2 to 2 is 4 units. And what's the distance between the y-coordinates? 4 to negative 4 is a total of 8 units. And so we can go 4 squared plus 8 squared is d squared. And that's 80. The square root of 80 is the distance, which is the same thing as 4 root 5 if you were to try to simplify the radical, because 80 is 16 times 5, so the square root of 16 is 4, and the square root of 5 is just the square root of 5. So let's write that down here. Root 16 times root 5. So that's how I arrived at that answer, 4 root 5. And our last triangle, the distance from 5 to negative 6, that's 11 units. And then the distance from 2 to negative 4, that's 6 units. And so when I set up the Pythagorean theorem, 11 squared plus 6 squared is equal to my distance squared. That's 121 plus 36. It's 157. All right, that's it for the distance formula. Thanks for watching. Be sure to comment, like, subscribe, hit that bell for notifications. Have a good day.